All right, hello, my wonderful students. This is the last part of the pre-foldable number 2 for section 2.4 parent functions. And for this one, we're going to go over two functions here. The two functions we have are our rational function or the reciprocal function and the greatest integer function, which is something we won't really use too much here, but I wanted to introduce it to you guys because I know it is in calculus, which is our goal, right? So for this one here, we can go ahead and just use our -2, -1, 0, 1, and 2. And we're just going to go ahead and plug it in now. So we have f of x, which is our f of -2 here, is equal to 1 over -2, which just gives us -1/2. F of -1 is going to be equal to 1 over -1, which just gives us -1. F of 0 is equal to 1 over 0. Ooh, but we can't divide by 0. That breaks the universe. So this is undefined. Okay, so this is undefined. And then we have our f of 1 is equal to 1 over 1, which gives us 1. And then our f of 2, which is equal to 1 over 2, which is equal to 1/2. So same thing this one, we go ahead and graph. We have -2, -1/2, -1, 1, undefined, 1, 1, and 2, 1/2. So the way this graph looks, it looks like this. So it gets as close as it can to the 1, to 0, and then it goes all the way down and gets as close as it can here. And this one comes from above, goes all the way there, and goes like this. Okay. The next one is called, so this once again was called the rational function. Oop, I forgot to change the color. Function. The next one is called the greatest interval function. The way this one works is a little different. It kind of looks like steps, but let's not use like regular digits. Let's use like stuff that's in between. So we can use -1.5, -0.5, 0.5, 1.5, and 2.5. So the way this works is whenever you have 0.5 as a greatest, 1.5. This one is annoying too, right? Because you have to write all these little blocks. And we end up getting that this is -2. Because that's the biggest integer that can be. And I'll explain that right now again. F of -0.5 is equal to, we just saw cricket in my classroom, -0.5. Ooh, this is hard to draw. I'm drawing these things right here, by the way. And this is going to be -1. F of 0.5 is going to equal to 0.5, which is equal to 0. F of 1.5 is going to equal to the of 1.5 equal to 1, and f of 2.5 is going to equal to 2.5, which is equal to 2. So the way this one works is, this one, like I said, it looks like stairs. So when you're at -1/2, which is going to be here, you can't really gauge the thing. So it's always, 1 and 2. So it's always based on the biggest integer that's possible. So the biggest integer that's possible for this one is our -2. But this can also go all the way up to 1, but doesn't actually hit there. Because then if we hit 1, that would be on this one here, right? Because that's at -1 here. So the greatest integer there would be -1. And this once again goes all the way to 0, but can't actually hit 0. So it covers all the ones in between and the previous integer, all the ones in between the previous integer. And as soon as we get to the next integer, it starts off the next one. So this one's at 0, and then goes, and these are all closed circles because these are included, right? And then it goes all the way to here, and these are not included. Okay, and we have to probably go one more here. Then we go to the next one at 1.5, which is in the middle here. The greatest integer is 1, so we're at 1. And it goes all the way to 2, but open circle. And last but not least, we have our 2.5 is in the middle here. So we're at our 2. We go all the way to our open circle at 3. So this is called the greatest interval function. Oop, I use green for some reason. Greatest interval function. And that's how it works. I mean, like I said, this is just a kind of brief explanation of what you're going to be using it for. In calculus, you'll go over it a little bit more in detail of what it actually does. But it just basically means you're using the greatest integer that you have.